Hey everybody, answers to the May 14th homework. First question was, given this triangle, this quarter circle, what's its polar triangle? Well, we know that we've got a right angle here, that's given, and we've already used this idea, that it's a right angle here and a right angle here. Let's just do a quick math proof of why those two right angles are actually so. So the equation for the unit circle, x squared plus y squared equals 1. Find y prime using implicit differentiation. Y prime is equal to negative x over y. So that would be the slope at any point. This point is the point 1, 0. So the slope of the tangent at this point is going to be negative 1 over 0, which is a vertical slope. And you can see a vertical line would be perpendicular to that radius. So that right angle is true. And then this point up here, point A, would be 0, 1. 0 for x, 1 for y gives me a slope of 0. Slope of 0 is a horizontal line, and a horizontal line would be perpendicular to that radius OA. So the right angles that we talk about all the time, when a radius goes to the circle, you get a right angle. It's really true. Now we seek the polar triangle for this triangle, and here's what you should have gotten for your answer. The polar triangle is the same triangle. The pole of OB is the point A. Let's see why. Here's a line that's perpendicular to OB, and here's a line that's perpendicular to OB, and those two lines meet here. So this point has to be the point that all the lines perpendicular to OB pass through. Same reasoning for B. B has to be the pole of OA. And we know that this has pole O, because here's two lines perpendicular to the outer circle. So that has to be the pole of the outer circle. So the polar triangle for this triangle is the same triangle, and this is true of any all 90-degree triangle in elliptic geometry. If you have a triangle that's all 90 degrees, then it is self-polar. That's what that's called. That's a big idea. We're going to have some theorems later on that don't apply to self-polar triangles. So self-polar is a weird thing. Only happens in this geometry, and it gives you instead of two different triangles, the triangle and the polar triangle, self-polar only gives you one triangle. So when you have a theorem about polar triangles, a lot of times the self-polar triangle doesn't apply. All right, another homework problem was this. Give yourself an obtuse angle at that central angle and produce the polar triangle. If you figured this out, very good. Here's why this red guy is the polar triangle. Here is an elliptic ray that's perpendicular to OB. And here is an elliptic line that's perpendicular to OB. The ray and the line meet at the pole of OB. Same thinking over here for the pole of OA. So join the poles by elliptic lines. So connecting to O, I get to use a straight line. Connecting to O, I get to use a straight line. And then I have this thing. And here's your homework problem for May 15th. There is a relationship that you can figure out between the red angle and the black angle. The big angle, AOB, and the small angle, POA, OPOB. What is that relationship? Can you figure it out? You can Google it if you want, but you have enough math to figure this out. So that's your setup. And we will be in touch. Bye.